Hello everyone, welcome back to this learning process. I am Disha from Sri Venkateshwara College of Engineering. This video is all about the statistical methods and the related topics from the course Mathematical Foundations for Computing, Probability and Statistics. Let us know about the contents that has been covered in this video. Introduction to statistical methods, statistical models, curve fitting, algebraic fitting of functions to data points, correlation and regression, types of correlation, coefficient of correlation, regression of a line, importance of statistics in daily life. What are statistical methods? Statistical models are tools to help you to analyze the sets of data. Experts use statistical models as a part of statistical analysis, which is gathering and interpreting quantitative data. Using a statistical model can help you evaluate the characteristics of a sample size within a given population and apply your findings to the larger group. While statisticians and data analysts may use statistical models more than others, many can benefit from understanding statistical models, including marketing representatives, business executives, and government officials. Here are six types of statistical models: mean, standard deviation, hypothesis testing, regression, sample size determination, analysis of variance. Let us move on to the topic curve fitting. Curve fitting is the process of constructing a curve or mathematical function that has the best fit to a series of data points, possibly subject to constraints. Here is an example of fitting a noisy curve by an asymmetrical peak model within an iterative process. Algebraic fitting of functions to data points, fitting the lines. So the straight line is identified by the equation y equals to ax plus b. The first degree polynomial equation is a line with the slope a. A A line will connect any two points, so a first degree polynomial equation is an exact fit through any two points within a distinct x coordinates. Fitting of a polynomial curve: if the order of the equation is increased to second degree polynomial, the equation results as y equals to ax square plus bx plus c, and the geometric curve is identified by the equation y equals to a plus bx. Correlation and regression. The word correlation is used in everyday life to denote some form of association. We might say that we have noticed a correlation between foggy days and attacks of dizziness. However, in statistical terms, we use correlation to denote association between two quantitative variables. We also assume that association is linear, that one variable increases or decreases a fixed amount of for a unit increase or decrease in the other. The other technique that is often used in these circumstances is regression, which involves estimating the best straight line to summarize the association. Types of correlation: positive correlation and negative correlation. A correlation is said to be positive if an increase or decrease in the values of one variable corresponds to an increase or decrease in the other. Example: height and weight, rainfall, and yield of the crop. A correlation is said to be negative if an increase or decrease in one variable corresponds to decrease or increase in the other hand. For example, increase in the price of the material and decrease in its demand. Coefficient of correlation: the degree of association is measured by a correlation coefficient denoted by R. It is sometimes called Pearson's correlation coefficient after its originator and is a measure of linear association. If a curved line is needed to express the relationship, other and more complicated measures of the correlation must be used. The correlation coefficient is measured on a scale that varies from plus 1 through 0 to minus 1. Coefficient of correlation goes like this: R equals to summation of x minus x bar into y minus y bar whole divided by n into sigma of x into sigma of y, where x bar equals to mean of x, y bar equals to mean of y, sigma of x equals to standard deviation of x, sigma of y equals to standard deviation of y, n equals to number of values. Regression of a line. A regression line indicates a linear relationship between the dependent variables on the y-axis and the independent variables on the x-axis. Here we have the formula to find out the regression of x on y and y on x, and also the coefficient of the regression, which is denoted by r. Some examples of statistics in our daily life. Weather forecasting. Statistics is used heavily in the field of weather forecasting. Forecasters will regularly say things like there is a 90% chance of rain today between after 5 p.m. to indicate that there is a high likelihood of rain during certain hours. In the field of sales tracking, retail companies often use descriptive statistics like the mean, median, mode, standard deviation, and interquartile range to track the sales behavior of certain products. Health insurance. Health insurance companies often use statistics and probability to determine how likely it is that certain individual will spend a certain amount on health care each year. In traffic engineers regularly use statistics to monitor total traffic in different areas of a city, which allows them to decide whether or not they should add or remove routes to optimize traffic flow. Also, traffic engineers often use time series analysis to monitor how traffic changes throughout the day so they can optimize the behavior of traffic lights. In the field of medicine, statistics is regularly used in medical studies to understand how different factors are related. Medical professions often use correlation to analyze how factors like weight, height, smoking habits, exercise habits, and diet are related. Why are statistical methods important? They are mainly important for designing more effective service for customers or employees, to create experimental studies such as a study to test a new product in development, for accessing the value of a potential investment, conducting scientific experiments. Thank you for watching this video. Please do like, share and subscribe.